Hello everyone, note down atomic structure. It's a easy to understand chapter. Application of circular motion from 11th. Concept of energy again from work, power energy from 11th. And electrostatics from 12th. With the help of this, we can develop different formulas used in atomic structures. We will start with Bohr's model. Now when we talk about Bohr's model, it means we are interested in those atoms which have only one electron. For example, hydrogen, which is a very basic thing. Or you can talk about, if we talk about helium, which has two electrons, then if you ionize the helium and only one electron is left, we can again use what? This Bohr's model. So Bohr's model is for a positive nucleus. We'll talk about hydrogen first. A positive nucleus and a negative electron orbiting around it. Let's say with speed v in a circle of radius r. So this is the very basic Bohr's model. Nucleus which is positively charged, electron orbiting around it at a distance of r with some speed v. And right now we are talking about hydrogen atom. So if you talk about Bohr's model, then what he says that all the electrons, they orbit in circular paths, circular tracks. And then at present you know that there is no strict orbit. Electron is both a particle as well as a wave. So instead of a sharply defined circular orbit, we have kind of probability profile that where exactly you can find an electron, which is also known as electron cloud. We are not interested in this type of electron cloud and all these things. We are interested in Bohr model, and according to Bohr's model, all these electrons, they are moving in what? Circular orbits. Write down this first assumption according to Bohr's theory. Write down the first assumption. According to Bohr's model, electrons always orbit in circular trajectories about the positively charged nucleus. About positively charged nucleus. Write down our second assumption. Angular momentum of an electron, angular momentum of an electron. What is angular momentum? Angular momentum is given by mv multiplied by r. This is coming from 11th rotational motion. This is the axis. Electron is moving in this direction, suppose. Then its linear momentum is m into v. Linear momentum p. And what is angular momentum? Angular momentum is linear momentum multiplied by perpendicular distance of linear momentum from the axis of rotation. So this is m into v, which is linear momentum. Its perpendicular distance is what? R. Now, Bohr says that this angular momentum is integer multiple of h upon 2 pi. Now, when people asked him why, he doesn't have any valid reason for this, that why it should work, just because all the experimental setup, all the results, all the experiments could be explained with the help of this, and therefore he says angular momentum is what? N into h upon 2 pi, where n belongs to an integer. And later on we'll see that if electron is a wave as well as a particle, then we can use de Bohr's concept, and from that de Bohr's concept we can develop mvr equals to nh upon 2 pi. So as of now, this is an assumption coming from Bohr's theory that angular momentum is equal to integer multiple of h upon 2 pi. These are the two basic things, that all the electrons, they are moving, they are orbiting in circular orbits, and these are stable circular orbits according to him, as long as they are moving in these circular orbits which satisfy this requirement. They do not emit any type of radiation. Why they do not emit any type of radiation? Why does he talk about not emitting electromagnetic radiation? According to Maxwell's theory, if you have a charge which is in acceleration mode, if it's circular motion, then the electron has centripetal acceleration. So if you have a charge which is in the accelerated motion, then it will emit electromagnetic radiation, and because of that its energy should decrease. And if energy decreases, then eventually, following a spiral path, it should collapse inside the nucleus. But that doesn't happen. So what Bohr says that if you satisfy this, then these circular orbits are stable orbits, and they will not emit any type of radiation. But as you know, Maxwell's theory is the dominating theory. If Bohr's model is taken in this way, then they will definitely release energy, and therefore this electron will collapse, which is finally clear with the help of quantum physics. So we are not into that. We are basically in elementary or something which everybody from class 11th and 12th can understand easily, and that is what the Bohr's model, a very easy to understand, and it gives you a base for that quantization, which also appears in the form of n over here. n belongs to integer, and immediately you see that there is something called quantization. N is 1, then it's not 1.1 or 1.9, it will be then n equals to 2, 3, 4, 5 and so on. This is also starting of quantization. The other quantization you saw in photoelectric effect. Energy of light is not continuous. It is in terms of what? Photons, energy packets. So you can have one photon h nu, you can have two photons 2 h nu. There's no way you can have 1.5 photons. So this was the starting of quantization and all, which ultimately developed the current understanding of atomic structure. We're not into that kind of thing, and therefore we'll limit ourselves to Bohr's model, which is applicable for one electron atom type of thing. So draw this much information and then we'll find V, energy and other things for the atomic model. Go down this much. So once we say that this electron is moving in a circular path, then this electron needs centripetal force, and this centripetal force is going to act towards the center of the circular path where your nucleus is present. This is requirement for circular motion. An object of mass m, if moves with speed v in a circular path, then it needs centripetal force, which is mv square upon r. This is a requirement, but there must be something which fulfills this requirement. What is that? Coulomb's attraction between a positive charge and another negative charge. What is that? This is K times Q1, which is E, Q2, which is E, divided by R square. We're talking about the hydrogen, and then we'll generalize the result. So this is the centripetal force mv square upon r. If this is hydrogen atom, then this is only a single proton. What is charge of a proton? E. What is charge of an electron? E. We are interested in the magnitude part. There is no need for you to write minus of E. Minus E simply tells us that this force is of attraction. So you are equating mv square by r with Kee upon r square, or you are saying that this requirement of centripetal force is being fulfilled by the force of electric field. So Fc is being provided by Fe, force of electric field. With this, you can find V in terms of R, which is coming Ke square m r. R and square cancel. You can easily find that V is root over Ke square all divided by mr. If we talk about hydrogen type atoms means you have a single electron in the orbit, but there are many protons present in the nucleus, then we will say that, or do one thing, first note down this and then I will modify the same thing and you will write everything again for a generalized situation. So this is the result for hydrogen atom, and then I will develop result for hydrogen type atoms. Put down this. Now write down velocity of an electron. Velocity of an electron for hydrogen type atoms. When electron is present in nth orbit. When electron is present in nth orbit. So I'll modify this figure and you can draw a separate thing. Suppose this is hydrogen type. So this is hydrogen type atom. We say that its atomic number is Z. And if atomic number is Z, that means there are Z number of protons present in it. So let's say there are Z number of protons present in it. This is a single electron. You've got Z number of protons. If there are Z number of protons, then the change will be what? You still have a single electron, but since there are Z protons, this E will become E multiplied by Z. There is nothing which is very difficult. What you did? You have simply replaced E or charge of a proton with charge of Z protons. This gives us Ez, charge of Z protons, multiplied by E, charge of the electron, divided by R square, and everything is same. So this gives us V as K square Z upon Mr. Now, if this is V, which is root K square Z upon Mr, we can do so many other things also, because we have second hypothesis which says that angular momentum is integer multiple of h upon 2 pi, where this n belongs to integer and also it represents what? The indexing of the orbit, which we are interested in this article. I told you that this electron is moving in the nth orbit now. So this is your nth orbit. If this is nth orbit, its radius is what? R. In any orbit, your angular momentum is nh upon 2 pi. From this we get the value of R as nh upon 2 pi mv. Put it here and you find V in terms of n. Either do this or you can do what? Let's put the value of R directly over here. You can put this value of R. It has a term of V under the root, cancel the root, square, and you will find the answer. And therefore I will be putting all these values in this relation directly. We have got m v square, which is this, which is equal to k e square z divided by r. R and r square cancel. This is your r. This r is mvr nh upon 2 pi. Now, let me further simplify this. I can always write this thing in this form. V mvr multiplied by V. That is coming K square Z. Take R over here. V square is V into V. You got the value of mvr, which is nh upon 2 pi. I put it here. This gives us nh upon 2 pi multiplied by V, that is K E square Z. This gives us V as K square Z into 2 pi divided by H into 2 pi divided by H. 2 pi divided by H multiplied by 1 upon N. This N is this N. This is N, this is H. So I've got V as K square Z 2 pi H 1 upon N. What is interesting over here? For a given atom, for helium, you have removed one electron, it becomes what? Hydrogen type atom, which has only one electron. Your K is fixed, your E is fixed, your Z is fixed, 2 pi H, everything is fixed, and therefore you can say that product of V and N is a constant. Product of V and N is always a constant. An important result for any examination. For hydrogen type atoms, indexing of the orbit and product of V is always a constant. Note down this much, and if you have understood everything up to this point, then write down yours in the comment box. Now try to answer this. Radius of nth orbit is proportional to n to the power x. Find out x. Radius of nth orbit is proportional to n to the power x. What is the value of x? Try to answer this simple thing. Only one response, and the answer is correct. I'm asking you proportionality of R. This is V. Let's multiply N both sides. So if I multiply N both sides, then this V and N, product of V and N is a constant. So if V N is constant, M is already a constant, shift the constant over here, H upon 2 pi is another constant. It tells you that R is proportional to N square. Listen again. I multiplied N both sides. This gives us V multiplied by N, which is a constant. Mass of electron is already a constant. You're left with R multiplied by a constant number. H upon 2 pi is another constant number. This is N square. So your R is proportional to N square. This gives us X2. And this part, again in itself, is an objective question. According to Bohr's model, radius of nth orbit is proportional to what? That's the answer. Now, answer this. V is proportional to R to the power Y. Speed in rth orbit, the orbit with radius R, is proportional to R to the power Y. Get me value of Y. Answer this. Look here. Vn is constant. What is n? N is proportional to root R. And everything is a constant. From this, what do you get? You get that n is proportional to square root of R. So replace this n with square root. This constant and the other constants together will be what? Another constant. This tells us that V is inversely proportional to square root of R, or V is proportional to R to the power minus half. So I'm asking you what the value of Y is. Y is coming minus 1 by 2. V and N, the product is what? A constant. This N from this is nothing but some constant times root R. So other things are what? They're constant only. This gives us V is inversely proportional to square root. But I'm asking you Y, and therefore this is coming minus half. Another result. Put on this. Now, I'm giving you a task. Find out kinetic energy, potential energy of this electron, and then total energy. Kinetic, potential, and total energy of an electron in its nth orbit, and get me all these values in terms of n. Or you can say I'm asking you the same thing, proportionality of Ke, Pe, and total energy with n. Again, something which is very elementary. Everybody knows what these things are. Total energy is nothing but sum of Ke and Pe. Should not take more than 1 minute. Try to answer these parts, K and P. If you can answer K and P, you can easily answer total energy of an electron when it is in its nth orbit. Note down this and try to answer this question. This is asking kinetic energy and its proportionality with n, and this is the function of V. What is kinetic energy? Half m V square. This is kinetic energy. Half m V. This is V. K E square Z. K E square Z 2 pi upon H whole square and then 1 upon n square. M K E Z pi H, everything is a constant. So you get kinetic energy is nothing but inversely proportional to square of n. Only one person could answer this. You've got the value of V in front of you. I intentionally left it over there. And then I asked you what is the proportionality of K with N. And only one could answer this. No worries. Let's see if you can answer potential energy now. Potential energy of electron in its nth orbit. Only one response, and that response is also not correct. What is potential energy? We have plus ZE charge and a negative electron separated by a distance of r. A nucleus which has a charge of plus Ze, an electron which has a charge of E minus, and these are separated by a distance of r. Now electron and the nucleus, they are what? Point charges. These are point charges. And if these are point charges, then potential energy of 2 point charges is given by K Q1 Q2 divided by R. This is the formula for potential energy, K Q1 Q2 divided by R. So what is the potential energy? K. What is Q1? Ze. What is Q2? Minus of E. When we use K Q1 Q2 upon R, we take Q1 and Q2 with proper sign. K Q1 Q2 divided by R. Now this is potential energy, but remember this potential energy in this form. This electron, you know that, was being pulled towards the nucleus with the force of F. So this force was what? This force is mv square upon r, and was provided by what? K times E ZE divided by R square. When we talk about force magnitude wise, we write ZE and E. For potential energy, things should be taken with proper sign. This tells us what? This tells us that and is also an important result. Look at the term kZe square. kZe square divided by R. So what is kZe square by R? This R in the R square term is gone. So the whole thing kZe square by R is nothing but minus of mv square minus of mv square. What is the advantage of this thing? Negative sign is for this kZe square by R. kZe square by R. R and square cancel is mv square. Now what is mv square? mv square is 2 times the kinetic energy. An important result. What is potential energy of an electron in its nth orbit? Relationship between P and K. Potential energy is negative of 2 times the kinetic energy. What is kinetic energy? This is kinetic energy, which is proportional to what? 1 upon n square. This is minus 2. Your proportionality part is still coming what? Same. There is no change in the proportionality. This is minus of 2. Well, let's save time since we have already proved that K is inversely proportional to n square. I am directly using the proportionality is still what? 1 upon n square. And also remember P is minus of 2K. Note down this and then we'll find total energy also. Now try to answer this. Total energy is K. Total energy is P. Total energy is minus of K. Total energy is minus of P. Option A, option B, option C, option D. Which option is correct? Answer this. Good. Correct answer is what? C. Total energy is sum of K and P, which is K. What is P? Minus of 2K. So this is minus of 2K. That is minus of K. Total energy of an electron in its nth orbit is minus of Ke. So what is total energy? Total energy is coming minus of, what is K? This is K. The K is M K square M K square e to the power 4. This 2 square is 4 divided by 2 is 2. Pi square divided by h square 2 and 2, this is the 2 part, m k square e4 pi square h square multiplied by z square divided by n square. Z square divided by n square. This is total energy of an electron in its nth orbit for hydrogen type atoms. For hydrogen, Z is 1. Now, for hydrogen, Z is 1. Tell me, do you have any idea of value of this number? The whole thing. Do you have the idea of this thing? What this whole thing is? Because we have seen this number a lot. And the hint is for hydrogen, Z is 1. What is the value of this whole constant? If you have the idea, then write down this in the comment box. Now the hint is you have seen this thing in terms of electron volts. This is the hint. You have seen the value in electron volts. Now tell me if you have seen this number before in your life. Minus of 13.6 electron volts Z square upon n square. Have you ever seen something like this before? 13.6, yes or no? Good, at least you have seen this formula. So that's how we arrive at this value using Bohr's model. Total energy of an electron in its nth orbit for hydrogen type atoms is minus of 13.6 electron volts Z square upon n square. For hydrogen, simply replace Z with what? 1. Note down everything. Now let's understand this second assumption for Bohr's model, that MVR is equal to NH upon 2 pi. Again, we understand this concept with the help of Bohr's hypothesis. What Bohr says that your wavelength is related to the linear momentum according to this formula. Lambda is h upon p. If this is the nth orbit, then in this nth orbit, electron as a wave forms n number of standing waves, stationary waves. These are n standing waves. When we show standing waves, we show them in this form. And what the whole picturization is, it's not in 2D, the thing is in 3D. It's something like this. Suppose this is the nth circular orbit, then all these waves, they're not of this type. The waves are of this type. This, not this, this. So in the nth orbit, this is the standing wave. What is standing wave? I hope you remember, if you have a simple string, you connect it at both ends, make both ends rigid, take a rubber band, and if both ends are rigid, slightly pull the rubber band at the middle point and then release it. So that rubber band starts oscillating. So these oscillations are of this type. This type. These are the oscillations. The same oscillations electron is producing according to Bohr's concept, and these oscillations are this, and then this, and then this, which is shown by the broken line. So that, just try to understand electron as a row. If you understand and take electron as a row, then suppose this is the row, then what is happening? This, that's how standing wave formation takes place. I hope you can see this thing. Look at let's have the white background. I hope you can see the wire. So this is the wire, up, down, up, down. That's how standing wave formation takes place. And if that's how standing wave formation takes place, then what is this length? This length is what? Lambda. How many waves are present? N. So what is total length of the orbit? Total length of the orbit is n multiplied by lambda. How many waves are present? N. What is this whole length called? Lambda. Total length is what? N lambda. But we know that its radius is r, and therefore this total length can only be 2 pi r. So your n lambda is basically what? 2vr. Now, according to Bohr, your lambda is basically h upon p. What is p? M into v. So I can replace lambda wavelength with h upon mv. This lambda, let's replace this thing with h upon mv. This gives us n multiplied by h upon mv, that is 2 pi r, which gives us what? Which gives us mvr, which is equal to n multiplied by h whole divided by 2 pi. So we have proved Bohr's second hypothesis with the help of Bohr's hypothesis. Bohr says that everything which is very small has a wave character. In fact, everything has a wave character. If things are very small, that wave character can be observed. So all these electrons, when they are present in their nth orbit, basically in terms of waves, we are saying that they are forming n standing waves. So if they are forming n standing stationary waves, then you can find the wavelength in terms of the linear momentum. Once you find wavelength in terms of linear momentum, you say that total length, which is 2 pi r, circumference of a circle, n lambda, replace the lambda part, and we get mvr, which is equal to nh upon 2 pi. So this was the success of Bohr's model and de Broglie's hypothesis. They could explain so many things for hydrogen type atoms. Although things are not currently done this way, but for you, this Bohr's model is something which is the useful model for understanding all those things. And as you get in advanced mode, not for JEE, I'm saying in advanced mode, if you continue with physics and all, then basics coming from these, the quantization and all, the particle nature, the wave nature and all these things ultimately give rise to all that which we currently know about atoms and the electrons. If you understood the derivation of second assumption completely, then write down yes in the comment box and then you can leave. Thank you very much.